I have my staining material set up next to the sink, but not in front of the sink. Then I will remove the clothespin and place the slide in the slide holder. Place it flat, and snug it down a little in the holder. Starting with the crystal violet stain, apply enough to cover all the smears, then leave the stain for 60 seconds. Towards the end of the time, you can prepare the bibulous paper and turn the water on. Let any excess stain fall into the staining tray, then carefully transfer the slide to the sink and rinse it thoroughly. I am trying to show the procedure for the camera, so don't try and recreate what I am doing exactly. Dry carefully in the bibulous paper. Take your time. Move the slide around, and press gently. The slide must be completely dry before moving on to the next stain. After the application of the first stain, your slide should look like this. Make sure that you have identified the smear side of the slide, and place it back into the staining tray, smear side up. Apply the iodine to the smear, and leave for 60 seconds. Then rinse the slide thoroughly. If you make a mess, clean it up so that it does not become a problem. I probably should have dried up my bench before I began drying the slide. Once again, dry the slide thoroughly before trying to move on. You should see an obvious color change after the iodine step. I have the gram-negative, E. coli, then the gram-positive, S. epidermidis, then the unknown. For this demonstration, I will be placing paper towel down on the bench, so I can better demonstrate the decolorization step. The decolorizing agent is 95% ethanol. Get the water running before you start decolorizing. Check that your bottle has a good amount of ethanol, and check that it is spraying correctly. Hold the slide sideways, then run the ethanol across the top side of the slide, back and forth, so that each smear receives the same amount of ethanol. One sign to look out for is the color of the wash liquid after it passes over the smear. You can see that it appears purple at first, as the stain is washed out of the smears. As soon as the wash begins to lose its purple coloration, this is an indication to stop decolorizing. The other important sign is that the known gram-negative smear begins to lose its color and reverts back to its original grayish appearance. As soon as you see these signs, wash the slide thoroughly with water. This stops the decolorization process. After washing with water, you can assess your slide carefully and continue decolorizing if necessary. As you can see here, my E. coli smear did not decolorize. There are a few possibilities to explain this. There is a chance it was not E. coli, even though it was labeled. And there is a chance the culture had become contaminated. But the most likely explanation was the age of the culture. The gram stain needs to be performed on fresh, 24-hour-old cultures. The cultures I used for this demonstration were not fresh at all. I will continue with the steps of the staining procedure, and hopefully next week, I will have some fresh cultures for a better demonstration of the decolorization process. The slide is dried in the bibulous paper. At this point I noticed that my gloves were wet and had gotten some stain on them. I decided to quickly clean up so that I didn't contaminate the remaining process. The slide is placed into the staining tray for the last time, and the stained safranin is applied for 60 seconds. You can see a bit of the red coloration from the safranin here. But I would expect the whole of the E. coli smear to be red. You can see that the S. epidermidis retained its black-purple coloration. Because the E. coli was not decolorizing, I was washing with the ethanol for too long. This washed out the thinner parts of the unknown smear, which then became pink after the safranin. Although, from experience, I would be almost certain that the unknown is gram-positive, the result I actually have here could be confusing or inconclusive.